In this video we're going to look at simplifying fractions. In particular we're going to look at simplifying algebraic fractions. I'm going to start here with a straightforward one, the 42 over 36. You know already that you would simplify this by dividing the top and bottom by 6, because both of these numbers are in the 6 times table. I want to take a moment here to explain why that works. What you are doing is you're identifying a common factor between the numerator and the denominator. What you're doing is you're essentially factorising both of these. 42 can be written as 6 times 7. That's the product of two factors. 36 can also be split into two factors. 36 is 6 times 6. And then what we do when we simplify is we go, I'm going to divide the top and bottom by 6, and it gets rid of that common factor. It reduces it down to 1. So I am left with 1 times 7 on the top and 1 times 6 on the bottom. And that is essentially what we have got to do when we are dealing with algebraic fractions. We have to think about them in terms of factors. So, looking at these two here, we've introduced some algebra. The first one, break it down and deal with it step by step. I've got some numbers, so I'm going to deal with them first. 33 and 44 can both be divided by 11. 11 goes into 33 3 times. 11 goes into 44 4 times. Now I'm going to go through each of the letter terms in turn. I have got an a squared on the top and an a cubed on the bottom. Now remember, what this means is I've got an a times an a on the top and an a times an a times an a on the bottom. So the most I can divide by here, I've got enough to divide by a single a and a second a. Essentially I'm dividing the top and bottom by a squared. A squared divided by a squared will leave me with 1, because anything divided by itself is 1. A cubed divided by a squared will leave me with a to the power of 1. I'm going to do the same with the b's. I've got b squared on top and a single b on the bottom. So the most I can divide by is a single b. Dividing the top by b, b squared divided by b will leave me with a single b, b to the power of 1, if you will. B divided by b on the bottom is 1. Now, I have simplified everything down there. Now I just need to multiply all these simplified factors together. 3 times 1 times a single b will give me 3b. On the bottom, 4 times a times 1 will give me 4a. And I have that fraction in its simplest form. Now the third one is us beginning to really look at proper National 5 stuff here. This third one hasn't actually been expressed in terms of factors. We've got 10c plus 25 on the top. Before we can do any simplifying of the top of the numerator here, we need to consider what its factors are. We need to factorise it. So the most basic sort of factorising we have is looking at this expression and going, what is the common factor of the two terms? Both of these are in the 5 times table, so I can take out a common factor of 5, and I have got 5 times 2c plus 5. So that's factorising at a National 4 level there. On the bottom, I have got a 15. Now what I could do if I'm really keen is I could write that 15 as 5 times 3. And that hopefully makes it really clear what I'm going to cancel out. I'm not going to write it like that though, because we normally wouldn't bother with that. So let's just put it back to 15. I'm now in the same position as I was in this one and this one here, where I have got something times something on the top, and on the bottom, 15 can be thought of as a pair of factors as well. Importantly, one of those being 5. So it means I can divide the top by 5 to get 1, and I can divide the bottom by 5 to get 3. Now, there is nothing that will cancel out this bracket on the bottom. 2c plus 5 is a factor. The only thing that will cancel this out is if I had another 2c plus 5 on the bottom. So I've simplified it there. Now I just need to tidy it up. I have got one lot of 2c plus 5. So I can write that with or without the brackets. I'm going to put it in brackets. Divided by the 15 got simplified to a 3. And I have now got that fraction in its simplest form. I can write it, like I said, with or without the brackets. Both are perfectly acceptable. Now, the fractions on this page here look like they're a bit more complicated, and they are to an extent. However, in terms of simplifying, the hard work has been done for us. These fractions have all been split up into their factors. So I can see I have got x plus 6 times x plus 3 on the bottom. I have got things being multiplied together. Similarly, in the second one, I have got x minus 3 being multiplied by x plus 2, and x plus 2 being multiplied by x plus 9. The last one, we've got a bunch of stuff being multiplied on the top and the bottom. So I can go ahead here and start cancelling out common factors from the top and bottom. So in the first one, I have got an x plus 3 on the top and bottom, so dividing by x plus 3 on the top will give me 1 there. Dividing by x plus 3 on the bottom will reduce that to 1. Because remember, dividing anything by itself will give us 1. This means I can write this as x plus 6 times the 1 divided by over 1. Now, I could write that as over 1, however that is not the fraction in its simplest form. We never write over 1. That is it in its simplest form. Again, think about what this means. This means this thing divided by 1. Anything divided by 1 basically doesn't change. The next one. We've got a common factor of x plus 2 on the top and bottom. So I can divide the top by x plus 2 and divide the bottom by x plus 2, changing those factors to 1. So this will give me x minus 3 on the top, x plus 9 on the bottom, because we've got 1 times the top factor, 1 times that bottom factor. Now, I cannot divide the top and bottom by 3, because this negative 3 and this plus 9, they aren't factors here. There is absolutely no multiplication going on the top or on the bottom involving this 3 and 9. So this is one of the reasons why I quite like leaving my factors in brackets, because it makes it clear that this is a one thing and this is one thing on the bottom, and they are not going to cancel each other out because, well, they're not the same thing. The next one. Some of you might find it easier to deal with this square bracket by just rewriting. I've got an x and then x plus 3 squared. So that is telling me I've got the x plus 3 being multiplied by itself. On the bottom, I've got an x times an x plus 1 times an x plus 3. And by doing that, it's clear how many of those x plus 3's I'm going to get rid of and how many I'm going to have left. So I can divide the top and bottom by x because there's a common factor of x on the top and the bottom. X divided by x gives me 1. I can divide the top by x plus 3 and the bottom by x plus 3 to reduce those factors to 1 as well. The second x plus 3, I don't have another x plus 3 on the bottom, so this one remains. The x plus 1, there isn't an x plus 1 on the top, so he also remains. So I am left with x plus 3 over x plus 1. These ones here are exactly the same as the ones on the previous page. The only difference here is these ones have not been factorised for us. We are going to have to do this ourselves. So hopefully by now you're resisting the temptation to go, that two things can cancel out, because, well, there is no multiplication happening here. All we've got is a bunch of stuff being added and subtracted. So we need to break the top and bottom down into factors. On the top, I've got x squared minus 2x. Both of these have an x in common. So I can take out an x and be left with x minus 2. So I've rewritten the top in its factorised form. The bottom. Now, we've got a trinomial, an x squared, an x, and a number term. So we know that this will factorise into 2 brackets. Now, if you've been given a question like this where you've been asked to simplify, you're guaranteed that this will factorise. And because there's no such thing as a trick question, we've got this bracket on the top, the x minus 2, so I know expect an x minus 2 on the bottom. I need to pick two numbers that multiply to give me negative 8 and add to give me positive 2. That will be positive 4 and negative 2. And look at that, told you so, the same bracket on the top and bottom. So my first step is complete. I've factorised the top and bottom. I have got a factor on the top and the bottom that will cancel out. Dividing the top and bottom by x minus 2 will reduce both of those factors to 1. I'm left with x times 1 on the top, and I'm left with x plus 4 times 1 on the bottom. The next one, again, I have to factorise it for myself. So the top, I've got this trinomial, 3 bits, an x squared, an x, and a number. So I know that that's going to give an x and an x for the x squared. These two terms need to multiply to give me 24 and add up to give me 10. Well, everything's positive there, so it's going to be plus and plus. 6 fours are 24. 6 plus 4 is 10. The bottom, we've got what's called the difference of two squares. I've got x squared minus 36, and 36 is a square number. This thing will also factorise to 2 brackets. X and x plus 6 minus 6. So you either just need to learn that this is the difference of two squares and will factorise to that, or you can treat it like the thing on the top. These two numbers need to multiply to give you negative 36 and add up to give us 0 x's in the middle. Divide the top and bottom by x plus 6 to cancel both of those down to 1, and I'm left with 1 times x plus 4 on the top and 1 lot of x minus 6 on the bottom. This is probably about as tough as it would get at National 5. It's exactly the same as the ones before, we just need to factorise them. The top is this difference of two squares. This is where it's useful to just recognise it. I've got 9x squared. I've got a 1. Right, well, 1, that's a nice easy square number. This is 3x times 3x. It's 3x and all of that squared. So this is the difference of two squares. So I can write this as a 3x plus 1 and a 3x minus 1 all over. Now again, because we've been asked to simplify this, because we're having to factorise, this is going to simplify. So one of my factors on the bottom is going to be one of these two brackets. This is more complicated. I wouldn't expect folks to be simplifying this in one step. So you would always take a little bit of space at the side of your page and you'd have a go at factorising it there. Now, this method has got a number of different names. Some people call it the magic number. Some people call it split the middle. But what I'm going to do, I'm going to multiply the 4 and the 3 to give me 12. And I need to consider factors of 12 that will give me negative 13 when I add them together. So it's positive 12 that needs to add up to give me negative 13. Well, 1 times 12 gives me 12, but it adds up to give me positive 13. Making both of those negative though, these will multiply to give me the positive 12 and add together to give me negative 13. So my 3x squared, my plus 4, they don't change, but I can swap that 13x, negative 13x, for negative 1x, negative 12x. I've split this middle term into two separate terms, but these will still tidy up to give me this negative 13x. I'm going to look at these first two, and I'm going to try and factorise them. They've got an x in common, and I'd have 3x minus 1. I'm now going to look at the second pair. Now, I basically want this bracket to appear here. If I take out a 4, I'm going to get a negative 3 and a positive 1. So I'm going to take out negative 4. Negative 4 times positive 3 will give me that negative 12. Negative 4 times negative 1 will give me that positive 4. These two bits here have got this bracket in common, so I can take out the 3x minus 1. 3x minus 1 got multiplied by x, and in the second case it got multiplied by negative 4. So I've factorised that trinomial, what we call a non-unitary, because it is not 1x, it's 3x squared. So the bottom can be rewritten like so. Top and bottom have both got 3x minus 1, so I can divide the top by 3x minus 1, and I can divide the bottom by 3x minus 1. So I've now got 3x plus 1 times 1, so that's not going to change, and I've got 1 times x minus 4. And that's that simplified. So, to conclude, you need to consider factors. Look for common factors to cancel out. And be prepared to do some factorising. If you remember that, you should get on okay with simplifying your algebraic fractions.